In this new model, we are going to learn the concept of sampling in inspection. So far, in every inspection that we have had in our models, all the entities that come through the process gets in, but when they go through the inspection, all of them get inspected and then they leave. And based on the result of the inspection, they go through their corresponding path, right? However, this is not always the case. In a lot of real world scenarios, we don't inspect all the entities. We are going to take samples from these entities and inspect some of those entities. What we want to learn right now is to see how we can implement the sampling and inspection in the simulation. Okay. So what I want you guys to do is to please create a new model in the folder for week 6 and name this model as precision gears dash. I have written inspection here, but I want you guys to write sampling and inspection, because the sampling part is important, because that's basically what we are learning. So then name your model as precision gears dash sampling and inspection. Okay. This is the structure of the model. We have a receiving dock. Two types of entities, gear A and gear B, arrive to the receiving dock. Gear A arrives without inter-arrival time of 5 minutes. Gear B arrives with an inter-arrival time of 10 minutes. Both of them exponentially distributed. Gear A then goes from receiving dock to gear hobbing, and from there goes to inspect queue. Gear B goes from receiving dock to gear milling, and from there goes to inspect queue. Okay. And then when they get to inspect queue, no matter if they're gear A or gear B, both of them wait in the inspect queue, and then they go to the inspection. However, we do not inspect all the parts. We inspect every 5th item in the inspect queue. No matter if they are gear A or gear B, it doesn't matter. When they wait in the line in inspect queue, we inspect every 5th item. So that's the whole sampling concept. And then the ones that gets inspected go to the inspect machine, and then they to the shipping dock and leave the system. The ones that should not get inspected go to the shipping dock, and then from there they leave the system. Okay. I have given you the processing time for the inspection, for the milling, and for the hobbing, gear hobbing process. And the receiving dock and the inspect queue, both of them have capacity of infinity. Everything else has capacity of 1. So I want you guys to please create a model, create the locations, create the 2 entities, create the 2 arrivals, and we do the processes together. Okay, so these are my locations. I have the receiving dock, gear hobbing, mill machine, inspect queue, inspect, and then shipping dock. For the receiving dock and inspect queue, capacities are infinity. For the inspect queue, since it's a queue, I have the first in, first out rule as well. I'm just making sure that the queue is queue, and the length is 20. That's the number I assigned, but it's not a big deal. Okay. And I have 2 entities, gear A and gear B, and I have 2 arrivals. Both of them get to the receiving dock 1 at a time from the start of the simulation. For as long as we run the simulation, inter-arrival time for gear A is 5, exponentially distributed, and inter-arrival time for gear B is 10 minutes, exponentially distributed. So here at the processes gear A, that is already at receiving dock, goes to gear hobbing. And from the hobbing machine, they go to inspect queue. And the processing time at the hobbing machine is normal 5-1. Okay, so then gear A went to the hobbing machine and to the inspect queue. we also have to bring gear B to the inspect queue and then take care of the whole sampling process and everything. So next line, I'm going to bring gear B from receiving dock to meal machine. And then from the meal machine to inspect queue. And in the meal machine, the processing time is uniform 6-2. Okay. Make sure to save, guys, as we proceed. Okay, now in inspect queue, I have now both gear A and gear B waiting in a line, one after another. So then in the next location where I am in is inspect queue, where I have both gear A and gear B. So now in the entity, instead of just choosing gear A or gear B, I can just say all the entities that are in inspect queue, all, no matter if they are gear A or gear B. And I'm at inspect queue. So right there is where I need to somehow implement the sampling concepts in simulation. So before we do that, let's assume we are in the real world scenario. Forget about simulation. You are in the real world scenario and you know every fifth item is going to be inspected. The guy that is performing inspection doesn't have the time to count these and see which one of them is the fifth item. The guy just wants to just pick up the parts that should be inspected and inspect it. And so he doesn't want to be worried about anything else. You are the one in charge of this inspect queue line, and you are the one who has to make sure every fifth item is going to be inspected. Can you tell me how would you do that in the real world?
We'd have like a ticker to count each time one thing gets to the queue.
Okay, so we have a counter, let's say, and that counter is going to count these items that are going to come to the queue. So this is item 1, item 2, item 3, item 4. And let's assume I get to item 5. What happens next?
You pull that one out.
Okay. You can pull that one out and then continue counting item 6, 7, 8, 9, and then you get item 10. You can pull that one out as well and maybe set them aside. But if you don't want to do that, if you don't want to pull them out and you just want to make sure somehow you mark them or put a tag on them or something, so the inspection person just picks the one that has the right mark or the right tag, you can do that too, right? When you get to the fifth item or when you get to the 10th, 15th, 20th item, just put a mark on them, for example. Then the inspection guys knows that, okay, I'm going to pick the part that has a mark, but the parts that do not have a mark should not be inspected. So then we are going to do a couple of things. First, we have to create that counter, which is going to count these parts that are coming to this queue. Every time a part comes to the system, this counter is going to be increased, and I'm looking for the times when the value of this counter gets to 5, 10, 15, 20, and so forth. So to be able to calculate, to put that counter in the system, I have to define a variable. I'm going to define a global variable. I'm going to call it quantity, or QTY, or quantity, or anything you want. That counter is definitely integer because it's going to be increased by 1 every time a new part comes to the queue. And that's the counter that is going to help me to count basically the number of parts that are coming to the queue. So let's define a quantity as a global variable. And then here, right at inspect queue, then the first thing I have to do every time an entity gets into the inspect queue, I need to increase this variable by 1. so that I know this is item 1, 2, 3, 4, 5, item 20, 21, anytime. Okay. Then how the value of this quantity variable helps me to know if I'm at 5th item, so that I know that's the one that has to be inspected. So I say if the value of the quantity somehow represents the 5th item. How do you think I have to write this to make sure the value of the variable quantity represents the 5th item, the 5th or the 10th or the 15 or 20?
Quantity mod 5.
Perfect. If quantity mod 5, if this equals to what? 0. Exactly. If quantity mod 5 is 0, that means quantity is a multiplication of 5. It's either 5 or 10 or 15, 20, 25, and so forth. Only in those scenarios, quantity mod 5 returns 0. If that's the case, then what? Then I want to tell somehow the simulation that entity for which quantity mod 5 is 0, which means it's the 5th entity that entered, or it's the 10th entity that entered, or the 15th entity that entered, I want to tell the simulation that's the one that has to be inspected. And I want to put a mark or something on it. I can define an attribute for these entities. And for those that has to be inspected, the 5th, 10th, 15th item, and so forth, I can change the value of their attributes to something so that the inspection guy knows that if the value of the attribute is this specific value, that means I have to inspect these parts. Okay, so I'm going to attributes. I'm going to define an attribute. I'm going to call it inspect tag. You can call it anything that you want. I'm going to call this attribute as inspect tag. And this attribute is going to get integer value. I decide to assign integer value to it, okay? And that's the tag that I'm going to use to specify if an entity should be inspected or not, okay? Give any name that you want to this tag. It's going to be integer. Now, when I go to the processing, okay, let me answer this first. When I defined this attribute, like what we said so far, all the entities in your simulation model are going to get this attribute, are going to get this tag. No matter if they are gear A or gear B, every entity you have in your system is going to get this tag. So now every entity in your system has an inspect tag. What is the initial value of this tag for all the entities?
0.
It's always 0. For variables and entities, the initial values are always 0 unless we change. So now, at this point, all the entities, gear A and gear B, have a tag. The value of this tag is 0 for all the entities. Now here I say, okay, if quantity mode 5 is 0, which means I'm in the 5th item or the 10th item or so forth, let's change this tag value. And I call the tag as inspect tag. So let's change the tag value to 1. It's already 0 for everyone. If the item has to be inspected, let's change the tag value to 1. And if quantity mode 5 is not 0, which means I'm in the either 6th item, I don't know, the 25th, 27th item, whatever, I'm not in the in every 5th item, then do not execute this line and don't do anything. So we are good. Only if I'm in the 5th, 10th, 15th, and so forth item, only if quantity mod 5 is 0, this line of the code is executed and the tag is changed to 1. Otherwise the tag stays 0, and that's it. That's all I want. Then all I need from the inspection guy is to look at the tag value and pick the right item to inspect. The parts that are at inspect queue, and we have already tagged them if they need to be inspected. So what are the possible destinations for these parts at inspect queue? What are the possible destinations? They
If it
either
needs-
go,
Oh, sorry.
ahead.
I was gonna say if it needs to be inspected, it'll go to the inspector, and if not, then just go straight to the shipping dock.
Okay, perfect. So then these parts, all of them, go to the inspect, or they go to shipping dock. Now, they go to inspect under what condition?
Every fifth item gets inspected.
Okay, and we already specified that every fifth item has a characteristic in our system.
They have
Okay.
the inspect tag.
The tag equals
They have
one.
a tag.
If their tag is 1, okay? I'm going to copy them. Okay, so they go to the inspect if their tag is 1. So in the rule, the user condition, right here, I'm going to put that condition. Send the parts to inspect if their tag is 1. You do not need to put if or anything. Simulation will take care of that automatically. You just put your condition. Where inspect tag is 1, send them to inspect. And for they go to shipping dock if inspect tag is 0. See, you don't need to put if. Simulation will write the if part for you automatically. If you write if, you get error. Just put the condition, simple and plain. Then we can say that, okay, all the parts that are at inspect are going to be inspected. The waiting time or the processing time at inspect is normal 6-2. And from there, they exit and they go, all the parts go to shipping dock. And then obviously from shipping dock, every part that gets to shipping dock, it'll exit the system. And we can still do all. However, I want you guys for the shipping dock to exit, I want you guys to do the gear A and gear B separately, just because I want to calculate a bunch of variables at the end and do logs and things. And I want to do that for gear A and gear B separately. So I want to know here exactly gear A is exiting the system or gear B is exiting the system. That's the only reason. Otherwise, you could just continue saying all go from shipping dock to exit, and that was fine too. So here I say gear A goes from shipping dock to exit, and gear B goes from shipping dock to exit. Make sure to save, guys. Run the simulation for 40 hours. Okay, so in my system, about 450 gear A and about 250 gear B left the system. Now, I want you guys to do a couple of calculations for me. I want you guys to calculate number of parts that get inspected. Obviously, that's something that simulation doesn't calculate for you guys automatically. I want you to calculate for me number of parts out of these total exits that we have. How many of them got inspected? That's what I need to know. Calculate total number of parts that got inspected. No matter if they are part A or part D, I don't care about that. Number of parts that got inspected, calculate that for me. And I want you guys to calculate the time these entities spend in the system from the point that they, so for disk A, I want you to calculate the time from the point that they start gear hopping operation till the time that they leave. And for disk B, I want you to calculate the time from the point that they start the meal operation till they leave the system. What I want to do now is to make sure that I want to count number of parts that got inspected. So I go to variable, I define a new variable, inspect quantity, which is integer as well. And then in that, I'm going to, and then the next question is, okay, where is the right place to increase that variable if I'm going to count number of parts that got inspected? The best place, as we just saw, is that after in the inspection, after performing the operation, I can increase that variable, inspect quantity, which counts number of parts that got inspected. I also want to record the time from the start of the hobbing to the end for gear A and the start of milling to the end for gear B. For that, I need to define an attribute for the time in to record the time of the start of these cycles. So I define a time in attribute, which is a real number. And then here in the processes, right at the start of the hobbing, right here at the hobbing machine for gear A, before I start the hobbing operation, right here, I'm going to save the simulation time at that point in this attribute that I define. And I'm going also to do the same for gear B at the milling operation, right at the start of the milling operation. Before milling operation starts, I'm going to do the same. I'm going to save the simulation time at the time in and then start the milling operation. So, and then when when the gear A gets to the shipping dock and is ready to leave the system, that's where I'm going to stop the clock. And I'm just going to say log. This is going to be gear A process, gear A. I'm going to say processing time in, and I'm going to do the same for gear B. When gear B is done at shipping dock and I'm going to send it out, right here I'm going to log gear B processing time and put the time in, which is the attribute that has the start of the process for gear B. And then the simulation, as soon as simulation sees the log function, it will automatically take care of everything. Okay. And as the question was asked, I don't have to define two different attributes for gear A and gear B to record the time where the operation starts at the hobbing or mill. I can just have one attribute, which is time in, and all the entities in the system, gear A, gear B, and no matter how many other attributes you have in your system, they are going to have the same tag, time in, and you can just save different values in this tag that all the entities have. And I just use this tag at these two operations for the hobbing and milling, and just save the simulation time at that point in that attribute, and just use that to calculate the time they have spent in the system from the start of the hobbing to the end, or milling, start of the milling to the end, using the log function. Okay, make sure to save, guys, and let's run it again. Okay, let's go to variable summary first. We see that, okay, for the number of parts that got inspected, what is the column that I have to look at? Number of parts that got inspected, inspect quantity.
Your maximum value?
Is the maximum value, 141 parts got inspected. So about 700 parts got processed and about 150 parts got inspected, which makes sense. Every fifth item got inspected. And let's go to the log. And here I see the processing time for gear A and gear B from the start of the hobbing operation or milling operation to the end. And what is the column that has the most relevant or meaningful value? Which column?
The average value.
Average. These are average time the part gear A spends in that part of the process and average time gear B spend in that part of the process. If there's no other question, I want you guys to save this model as it's the same model. I just want to show a little modification. So I'm going to keep it as the same name and then maybe a version 2 at the end. So save it as a new model in the same folder. At the end of the name, just put version 2. The only thing I want to do here is at the inspect queue. Okay, we all said, okay, let's do if quantity mode 5 is 0, then do this thing. However, if I don't do that, if I just look at quantity, and I said, okay, if quantity is 5, then change the tag to 1. What else do you think I have to add here? So I'm looking at the quantity, part 1, 2, 3, 4, 5. Quantity is 5. Now I change the tag to 1 so that the inspection guide knows he has to inspect the part. If I want to use this structure, this logic, what else do you think I have to do here so that I can still use if quantity is 5 for the 10th item or for the 15th item?
You need to reset quantity to 0.
We have to reset the quantity to 0. So when I get to the 5th quantity, right here, I assign the tag of 1. And also, I'm going to say that, okay, quantity, let's put 0 in the quantity. I'm going to reset it. So when the 6th entity gets here and these lines of code are going to be executed, then the quantity starts from 1 again. For the 6th entity, quantity is 1. 7th entity, quantity is 2. All the way till I get to the 10th entity. And then quantity again becomes 5. Okay, so as when I get to the 5th item, the 5th, 10th, 15th, whatever, I always have to set the quantity back to 0, reset the quantity back to 0, so that I start counting again from 1, 2, 3, 4, and then the setting back to 0 in the 5th part. For these 2 lines to be executed right, if quantity is 5, what else I need to do here for these 2 lines to be executed correctly? That's an if statement. And I need
The
to
brackets.
brackets. Exactly. I'm executing 2 things after if. So if I want to execute 2 things together after if, I have to use brackets. Otherwise, do you know what happens if I don't put brackets? How these lines of the code is executed if I don't put brackets?
It'll just keep resetting the quantity to 0.
If I don't put brackets, this is how it's going to be executed. If quantity is 5, this line will be executed. If the quantity is, and then quantity will be set back to 0 no matter what. If the quantity is not 5, this line will not be executed, but I'm still going to put the quantity back to 0. As if I'm always resetting the quantity back to 0, which is not what I want. So if this condition holds, I want these 2 lines to be executed together. And for that, I need begin ends or open bracket and close bracket.